Well, dear students, here I have written certain nuclear reactions which are incomplete. You are asked here to complete the reaction. It is just for sake of practice, nothing else. The lower suffix tell you atom number, this mass number. In any nuclear reaction, the sum of atom number does not change overall. Sum of mass number on right side is equal to mass number on left side. Atom number on right side is equal to a number of left side. So in first reaction it is 88 radium 226. Actually I have written so many because so that you may come across the atom number and mass number of elements and try to learn some. Radon 88. So it is 88, it is 86. So difference is 2. And you may remember here that 2 is the atom number of helium. जैसे यहाँ लिखा है 2He. But difference 4. So you can write here it is 2He4. Now 15p31. 15p30. P for phosphorus. Remember 15 is the atom number of phosphorus, 14 is the atom number of silicon. So now number has decreased, but mass number has not changed. In which chemical reaction mass number does not change? Beta decay. But beta decay I told you are two types, positive beta decay and negative. In positive beta decay you get positron, antipart electron and neutrino. So here there are two gaps. So here you write +1 E0 or neutrino. Some people write +1 E0 4 लिखते हैं वो बीटा प्लस. तो मास नंबर कंसेप्ट क्या हो जाता है ऐसे लिखने से? We should write mass number here. I hope you are getting. I told you that sum of atom number on both sides. On left side, right side equal to sum of equal to atom number on left side. Sum of mass number on right side is equal to sum of mass number on left side. 15p30, 30, 0, 15, 14 plus 1, 15. Plus 1, na? Here we write only 1, you can write plus 1. Positron. 42 molybdenum. 94 plus 1s2. You know 1s2 is deuteron. So 43. Mass number has become, क्या भाई? Total mass number तो complete हो गया. Sorry, atom number कहाँ गए? Atom number तो complete हो गया 41. तो next जो कमी होगा 0 mass number होगा. 0 mass number for neutron and it is 1 here at mass number 1 neutron. ये नीचे लिखा भी है यहाँ पर. जैसे लिखा 4Be9 is equal to 6C12 0 and 1. If you remember, it is the by this reaction neutron was discovered. So what should be there? 6, 4. So 2 is the atom number helium. Or 4, 9 plus 4, 13, 12 plus 1, 13. 84 polonium, 210, 206. So difference is 2. So 2 is the atom number of helium, 2He, 4. 206 plus 4, 10. So this way you can fill up the blank here easily. It is 2He4 this side, here mass number 5 and atom number 5, 2 is there, 3 should be the atom number, and remember 3 is the atom number of lithium, and mass number you can complete, it is 11, it is 4, 11 minus 4, 7. So that way you please try to fill up the blank 1He3, ये थोड़ा मुश्किल आपके लिए. How the metal number has increased? Here number 1, here 2. So here we will have -1E0 plus neutrino, anti-neutrino. And rest of you can fill up and try to get some more reactions from books. In our NCERT book also, some reactions are there. You can see on page, here on page 462. Page number 462, question number 13.6, page number 462. Please see these reactions and verify the answer from your book. Now I come to some numerical based on rate of reaction. You can have a, क्या बोलते हैं इसको, this snapshot. So now I come to some other questions. You can see this question by pausing the video there and write the equation on your copy and do them. In our book there are some short examples which are generally asked in exam, in competitive exam. I will be solving many problems now. There is one question on rate of reaction. Half life of uranium-238, T half for uranium-238 against, I have given the example also, against alpha decay is 4.5 10 to the power 9 years. Yes, 4.5 10 to the power 9 years. So you are asked here, what is the activity of 1 gram sample? What is the activity from 1 gram of 92 uranium-238? Activity means rate of activity. What is the rate of radioactivity from 1 gram of uranium-238? You are given half-life, T half, 4.5 10 to the power 9 years. My dear student, try to have some tricks. For some tricks you have to learn something. 1 year, how many seconds? I have told many times. 1 year is 3.16 10 to the power 7 seconds. Remember this. Actually, we need this to convert this into second. 4.5 into 10 to the power 9 into 3.16 into 10 to the power 7. So 3.16 into 4.5, 5 is 38 or 5 is 15. 6 and 12, 0, 12, 12 and 4 and 1, decimal after 3. So it is 14.22 10 to the power 16 seconds. It will be needed here because you are asked rate of activity. So rate of radioactivity, so here 4.5 10 to the power 9 years is equal to 14.22 10 to the power 16 seconds. Now RT, rate of activity. T का मतलब because rate keep on changing with time. I have told you. Is lambda nt, and lambda is equal to 0.693 upon T half. What is nt? Number of radioactive nuclei present in 1 gram uranium. So here nt 1 gram. 238 gram has 6.023 10 to the power 23 nuclei. 1 gram 92 gram, sorry, 238 gram is this. So 1 gram is 238. So it is here 6.023 10 to the power 23 upon 238. तो इसको सॉल्व करना है आपने. You can round off here. It is 0.7. It is 6. 10 to the power 23 upon T half. 1.4 ले सकते हैं आप. 1.4 10 to the power 17 238. It is 2 jar, 3 jar. So 3 upon 238 into 10 to the power 23 minus 17. I know 6, but मैं दिखा रहा हूँ, आप ऐसे कर सकते हैं. When you are doing problem in an exam, leave this part vacant and do rough work here. Don't run the page. So 10 to the power 6. Then how to solve it? Take it as 300 upon 238. 10 to the power 4. 300 divided by 238. 1 jar. 2 and here it is 96. 0.0. It is 2 jar here, 3 jar. 69 jar, nearly, yes. So nearly it is 1.23 कुछ आएगा per second. Or becquerel, you can write BQ. BQ. And in book the answer is given, yes, 1.23 given है. If we divide 1.23, so please don't get bothered about such problem. These are very interesting. Sometimes you are not required to find NT. Number of radioactive element nuclei are given. You have to remember only RT is equal to lambda nt. And remember that lambda is equal to lambda half decay constant equal to 0.693 upon T half. अगर आपको ये याद रहेगा तो आपको प्रॉब्लम नहीं होगी. It was a sole example of this 13.4. Now, regarding this, now I come to here a very good question, which is we should know if we have studied physics and we have studied radioactivity. So, one technique here is called radiocarbon dating. There is a question on radiocarbon dating. Radiocarbon dating. कोई भी पढ़ा हुआ आदमी आपसे पूछ सकता है. If you have passed class 10 and you say we have learned radioactivity, though it is not in our mentioned syllabus, but general awareness it must. Radiocarbon dating is one technique for what? Of knowing the age of dead organism. Every living being takes food, and in food it takes carbohydrate, means carbon is there. Carbon has two isotopes, C12 and 6C14. Actually, plants prepare their food by absorbing CO2 during photosynthesis, and then in CO2 this proportion of this is fixed, and 6C12, 6C14 is radioactive emitting beta decay plus 7 and 14 plus antineutrino. So from our body the carbon 14 keep on decaying, but as much as it is decays, the same is assimilated by us in the form of food. So rate of reaction, rate of activity from our body of beta decay remain constant. This remains constant. But when any living body dies, it assimilates no more C14 because it stops taking food, and hence rate of radioactivity keep on decreasing. Half-life of carbon 14, here it is given 5730 year. 5730 years is the half-life of C14. So by measuring the rate of radioactivity from given sample, dead sample as well as living sample, by comparing them we can find out the age of the dead organism. This is called radiocarbon dating, and we are using, our archaeologists are using this device, this method. So here is a question: normal activity of living carbon containing matter. This is 13.8 on page 462. Normal activity of living carbon containing matter is found to be 15 decay per minute. RT, 15 decay per minute. So per second 15 upon 60. इनके 1/4 या 15 में ऐसे इनको बात नहीं. The activity arises from the small portion of C14 present in the stable carbon isotope C12. When organism is dead, its interaction with the atmosphere ceases and its activity begins to drop. Then from the known half-life 5730 and measured activity of the age of specimen can be approximately estimated. This is the principle of C14 carbon dating used in archaeology. Suppose a specimen from Mohenjo-daro gives activity of 9 decay per minute. It is suppose R0, it is RT, so it is 9 decay per minute. So you are asked estimate the approximate age of Indus Valley civilization. Time हो गया यार. So I have told you rate of reaction. RT is equal to R0 e to the power minus lambda t. Here RT is 9, R0 is 15, or e to the power minus lambda t, or 9 upon 15 is equal to e to the power minus lambda t. It is 15 second 90.6 e to the power minus lambda t. Or you can write as 3 3 जा 3 5 जा, ठीक तो है। तो और 6/10 या 3/5 3/5 e to the power minus lambda t, और 5/3 e to the power lambda t. Using the definition log, lambda t is equal to log of 5/3 on base e, or lambda equal to 0.693 upon t half into t, 2.306 base 10 log 5/3. T half 5730. So t equal to t half into 2.306 upon nearly 0.7 or log 5/3. T half 5730. Yes, 5730. और अगर हम इसे कहेंगे 7 कितने में 1 7 7 3 7 5 like this, और log 5/3 means log 5 minus log 3, log 5 minus log 3. Solve it. How will you solve it? Logarithm is required here. Yes, I have the log table here. So log 5 means 0.56, sorry, it is 5730 into nearly 4 into 0.6990 minus log 3 is 30. log 30 मां 3 पे देखना 47.4771 इतने ईयर आएगा. You can solve it yourself. So that way we can find out the age using radiocarbon dating. This question may be asked in another form. Okay, the present rate is this and initial rate was this. So what is the time or anything? Just अभी मैं बता रहा हूँ question. So please watch this video, very important video I have given you. You please watch this, make note of this, write all those reactions which I have given in this one, so that you may learn the number and name of the atomic elements. Thank you.